So we did the polynomial graphs before. That's what the quizzes are going to be on tomorrow. You're going to see a certain graph. You're going to have to find the x-intercepts, y-intercepts, leading coefficients, and possible lowest possible degree for it based on the number of turns. If you just take the number of turns and add 1 to it, that's the lowest possible degree that you can. 2.2, we already did long division of polynomials. Hopefully you remember how to do that. Okay, make sure you practice that every day. There's tons of practice problems on the website for you to work on, so definitely don't lose that skill of long division. We did review it yesterday, though, and we'll pretty much try to review it every day up until the test. Remainder and factor theorem. If you remember, for remainder theorem, if you just plug the root of the bottom, you set it equal to 0 and solve. If you plug that value into the top part, it will tell you if it's a factor or not based on the remainder. If the remainder is 0, if the value is 0, then it's a factor. If it's not, there's a remainder. Okay. So today we're going to start on 2.2.3, which is finding solutions of polynomials. We kind of did this yesterday a little bit, so we're just going to do it a little bit more today. So start a fresh section of your notes, and then make sure you pay attention, ask questions if you got them while we're going over this. This is going to be 2.2.3. It's all about finding solutions of polynomials. And to kind of review what that even means, what it means to find a solution, I'm going to review this stuff from the previous unit because you have to know it for this unit as well. So we're going to try to find the solution of the following equation. It's going to be 3x plus x squared is equal to -7. Okay. Before we start, I want to ask, how many solutions should I have for this one based on the degree? 2. Okay. Based on this right here, I should have 2 solutions. Okay. And since you just did a problem, I'm going to kind of do this one with you, or we can do it all together is what I'm going to be saying. So first thing you want to do is to find the solutions of this is you want to factor it, or you shouldn't even, I shouldn't say factor it. You have to get it in standard form first. So you want x squared first plus 3x, and then we're going to add 7 to both sides. So it's going to be plus 7 here is equal to 0. So essentially what I did so far is I just added 7 to both sides. And then this canceled. And then I reordered the left side. Okay, you need it in this form to be able to do quadratic formula, so that's why I did it that way. We are going to say that x is equal to -b, which is -3, plus or minus the square root of b squared, which is 9, minus 4ac, so it's 4 times 1 times 7. Like that. And then we're dividing all of this by 2 times a, which is just 6. Okay. You should be able to do this by now quite easily. It was on your Unit 1 test. It's not going to go away anytime soon. You're going to have problems like this in this unit. So make sure you know how to do this. Right here, this is 28. So it's 9 minus 28, which is just going to be -19. So you're going to have -3 plus or minus the square root of -19, all divided by 6. Okay, you cannot have a square root of a negative because it won't make any sense. So you have to pull the I out of there. And if you pull the I out, then you don't have to have the negative anymore. And you'll have something like that as your solution. Wait, why did I do 6? Why is someone not yelling at me? I was looking at the wrong one. This is embarrassing. This should be a 2. Come on, Scott. That's embarrassing. I don't know why I was looking at the B for that. I think it's because I was looking up here. I don't know. That's embarrassing either way. Anyway, that's your answer for this one. Okay. Now you might be thinking, well, how is this 2 answers? Well, it's because it's plus or minus. That's 2 answers. It really should say plus and minus. Okay. And then another quick review. What we're going to do here is to write this in factored form. So that original equation, to write that in factored form, you could write it as this. It would be, well, you have to write it as this. It would be x minus 3 plus root 19. I forgot the I. Throw the I in the back, I guess, this time. Okay. Well, that's the plus version of it. And then you also have to do x minus the minus version of it. Okay, so this would be the factored form of it. This would be equal to 0. Make sure you know how to do that. You just take whatever the roots are and do x minus each of them. That's all it is. That should be a review from the previous unit, though. So that is 2 answers. If you notice, there's 2 linear factors on this. That should always happen too, based on whatever the power is. 2 linear factors. Okay. Let's keep going here. Let's do another example. Let's say that we have x squared plus 2x plus 1 is equal to 0. Okay, I want the solutions for it and factored form. So I want solutions, and then I want factored form of this. It's already in standard form, so that makes it a little bit easier. All right, so we're going to say x is equal to negative b, which is negative 2, plus or minus the square root of b squared, which is 4, minus 4 times 1, which is just 4. And then we're dividing this by 2. Okay. Anytime this is a 0, it's plus or minus 0, that's technically 2 answers. Okay? So when you solve this out, it's negative 2 over 2. It's negative 2, and then I need to write multiplicity 2. Okay? If you forget that it's plus or minus 0 is technically counted twice, just think you have 1 answer here and you should have 2. So that's a sign that you need to do multiplicity 2. Okay. Another way of thinking about it too is when you write factored form. If you did factored form on this, it would be x minus negative 1 if there's only 1 solution. But since it's multiplicity 2, you square it. Okay, the minus minus becomes plus plus, so you end up with x plus 1 quantity squared equal to 0. If you wanted, you could also draw or write it like this, where it's x plus 1 times x plus 1, and then you can really see the multiplicity of it being 2. But if you notice, this is different than the one we just did. The one we just did had 2 different roots because it had the plus version and the minus version. This one only has the negative version, and there's 2 of them. Okay, so that's a review of 2.1 with the multiplicities. Now, since the multiplicity is even, the graph there should what? At negative 1, x equals negative 1. Should it go through it or should it bounce? It should bounce, right? Okay. So the solutions for this are here. It's just negative 1 and negative 1. And then the factored form is down here. Okay. So essentially we are doing 2, 2, 3 right now, but it's a review. But technically quadratic is still a polynomial. So we are still solving this out. Okay, so I did a really complicated one, and then I did like an easier one. Now I'm going to do one that's kind of in the middle. Okay, well, it's kind of actually just completely different, really. So say I had x squared plus 4 is equal to 0. Okay, if you wanted, you could use quadratic formula on this, but it's easier just to solve it as it is. Okay, so this is x squared plus 4. You can subtract the 4 on both sides, and you get negative 4. Do the square root of both sides, plus or minus every time you do the square root. And you're going to be left with x is equal to plus or minus, I'm going to pull that I out of there, I root 4. The square root of 4 is 2, so you just get plus or minus 2i for that one. Those are the solutions to this. So if you wanted to, you could write it in factored form. It would be x minus 2i and x minus negative 2i, which really is just a plus plus. So this is factored form for that. Okay. If you notice, you have 2 answers for both of them. You have two linear factors on the bottom, and you have 2 solutions right here, which is what we should have based on that power right there being 2. Okay. So this is all great. We're doing all this stuff with 2. We've done these problems before. So now I'm going to give you one that involves something where it's to the third power, essentially. So I think I'm done with this sheet here. All right, let me find the problem I'm thinking of. Oh, here we go. This will also be a kind of a review for Unit 1 as well. So if you are planning on remediating Unit 1, you're kind of in luck today. All right, this one's going to be x to the 4th. So say we have some polynomial, and it's equal to x to the 4th minus 3x squared minus 4. Hopefully you see that this is actually just quadratic in structure. Okay, if you remember that. This one doubles. If you double that one, it goes to the 4. So what you can do is do u substitution on this and say that your u is equal to x squared, and then rewrite the entire equation to be u squared minus 3u minus 4. Okay. Now let's look for the solutions on this. So the solutions, so I'll write that down here. So we're looking for the solutions of this. That means we have to set this equal to 0 and solve. Okay. Now we should get 4 answers out of this. Okay. 4 answers should pop out here. So we're going to use u, this u right here. We're going to do quadratic formula. So it's going to be negative b, which is just going to be negative 3, which is just 3, plus or minus the square root of b squared, which is 9, minus 4ac. That would be 4 times 1 times negative 4, which is negative 16. So I'm going to put a negative 16 in here. And we're dividing this by 2. So plus. This ends up being the square root of 25, which is just 5. So your final answer for u is 3 plus or minus 5 over 2. Okay. So that's going to be 3 minus 5 over 2, which is going to be negative 2 over 2. And then 3 plus 5 over 2, which is going to be 8 over 2. So that means we have u is equal to negative 1 and u is equal to 4. And if you remember, our u is equal to x squared. So I'm going to put x squared in there for u and solve for x. And you should end up with 4 answers. So this one's going to be plus or minus I, because you do the square root of both sides with the plus or minus. This one's going to be plus or minus 2, which is 4 answers, which is how many we're supposed to get. So those are all the solutions. Okay. What about factored form? Okay. For factored form, since we have the solutions, all you have to do is subtract, do x minus each of the solutions. So x minus I, x minus negative I, which is just x plus I, x minus 2, and x minus negative 2. Okay. And then you can simplify these. And there you go. That's factored form for it. If you notice, there are 4 linear factors. It's always going to match whatever the degree is. Okay. Always, always, always. So where we ended right here, this is actually what I'm going to use to teach the next concept. Okay. If I multiply all of this out right here, these 4 things here, you would actually get where you started, which is this part right here. Okay. Now I'm going to show you that, but I don't want you writing it down because it takes such a long time to do. And I want to kind of go faster, and it's not that important because we're going to do this together next anyway. So what I'm going to do is I'm going to multiply these 2 things together first. So it's going to be x minus I and x plus I. Come on. Okay, again, you don't have to do this necessarily because I just kind of want to go through it quick. We're going to do plenty of practice. I just kind of want to prove to you that you do end up with the same thing. This is negative I squared for this one. Okay, this one right here, it's x minus 2 and x plus 2. Okay, not as straight as the other one, but that's okay. Negative 2x, 2x, and then negative 4. Okay, now if we simplified this out, this would cancel. This would be negative negative 1, which is just 1. This would cancel. So you're left with x squared plus 1 and x squared minus 4. Okay, but it still does not look like where we started. It should be, whoops, it should be x to the 4th minus 3x squared minus 4. So I still need to expand this out. This is part of the reason I didn't want you to write anything down for this. So we're going to do x squared plus 1 okay, like that, and then x squared minus 4. I'm going to multiply all this out here. We get x to the 4th, we get x squared, we get negative 4x squared, and we get negative 4. Okay, add all of these up, you end up with x to the 4th minus 3x squared minus 4. And if you notice, that's what we got to begin with. Okay, now do I expect you to multiply all that out? No, that took me a year, and I'm a teacher. Okay, we're going to be doing ones that are similar to that, but they're going to be easier. It's not going to be x to the 4th because it just takes way too long to multiply it out. Okay, so we're probably never going to go over 3, to be honest with you. So that's actually the next problem that we're going to do. Is I'm going to give you the roots, the solutions, and you're going to create that polynomial. So we're basically going to be going backwards. It'll make sense once I write the problem down. I just need room, so I'm shrinking that down. All right, so we are on number 5, I believe. Okay, number 5, I'm going to say write a polynomial equation with the given solutions. Okay. So part A, here we go. So I'm going to say that one of the solutions is going to be 1. Another solution is going to be 2i, and complex numbers always come in pairs. So you have to do plus or minus 2i for this. Okay, so here I'm starting with the answer, and I'm trying to create the equation. Okay, if you remember before, we started with the equation, and I was looking for the answers. I was looking for the solutions. Okay, so we're going to start with the solutions and try to find the equation this time. So it's just going backwards. That's what 2, 2, 3 is all about, just that going backwards part. Okay, so to do that, I'm going to write each one of these as being subtracted from x, as a linear factor. So it's going to be x minus 1, x minus 2i, and x minus negative 2i. Okay, that's in factored form. To make it an actual polynomial, I have to multiply all of these out. Okay, and if you remember, I did that last time with 4 of them. It took a little bit. 3 doesn't take as long. And I'm going to show you a little trick as well. Okay. Whenever you multiply conjugates, so this is evil twin, this is good twin. And let me rewrite it really quick so maybe it'll be easier to see. Whenever you have conjugates like this, like these two right here, I would always multiply those out first because they have a shortcut. You don't even need the to grid it out for this one. All you need to do is square the first one, and this only works for conjugates, by the way. You square the first one, you square the second number, and you subtract them. Okay. I'm going to highlight this so you kind of see what that these two things are equal. The two of the things that are highlighted in yellow right there are equal. Okay. If you want to grid it out, then grid it out. You're going to get the same answer. I'm just showing you the shortcut. Whenever you multiply good twin by evil twin, you can just square the first one, square the second one, and subtract. It does not work for any of the other ones, though. It's only conjugates. Okay. Well, let's simplify this. This is going to be x squared minus 4i squared okay. Well, I squared is -1, so it's going to be -1. So this is just going to be x squared plus 4 and x minus 1 here. And the last thing to do is grid that out. Okay, so that's what I'm going to do. It's going to be x minus 1 and then we just grid it out here. So it's going to be x to the third minus x squared 4x -4. So your final answer would be if you just add all those up. So it would be x to the third minus x squared plus 4x minus 4. So now what's great about this is that we started with 3 solutions, so your answer should be x to the third. And it is, it's x to the third, so that kind of tells us that we did it right. Okay? The only way that this could really be like trickier, I guess, is if I did something like this. What if I said originally, don't write this down, but what if I originally said that that 1 has a multiplicity of 2? Okay, you have to square that and still go on through all the other stuff. But then that's going to take a while, so that's why I did not do that squared there. But just know sometimes there is a multiplicity that you have to deal with. In fact, the next one we're going to do involves multiplicity. Okay. But what I just did right there is part of section 2.2. Okay, it's still related to what we were doing before. It's just going backwards, starting with the solutions and finding the equation. So let's do another one. Let's do part B. Let's say that one of the solutions is -3, multiplicity 2, and another solution is just 5. Okay. Technically speaking, how many solutions do I have here? 3. You count the multiplicity, so you have -3, -3, and 5. So it's 3 possible solutions. Okay, so if you remember, all you have to do is subtract whatever the solutions are. So it's going to be x minus -3, but it's a multiplicity of 2, so I'm going to square that one. And then it's going to be x minus 5 there. Okay, now if you realize that you keep doing this plus plus, you can just start with just by writing x plus 3 squared. You don't have to do that multi-step. I'm just a teacher and have to kind of show where all my thinking's coming from. But if I plug any of these values in, -3 or 5, into this equation right here that I just highlighted, you should get 0. Okay, otherwise it's not a solution. So if you plug 5 in there, you get 8 squared times 0. That's 0. If you plug -3 in there, you get 0 squared times -5, which is also 0. Okay, so that's one way of checking by plugging in these solutions to your answer here, and it should be 0. The last step is to multiply all of this out. So if you grid out x plus 3, you should get x squared plus 6x plus 9. Okay, so this part right here is equal to this. And then we're going to multiply it by x minus 5 here. And then you just have to distribute the x minus 5 to each of those terms. Okay, so we're going to do x minus 5 times x squared. Then we're going to do x minus 5 times 6x. And then we're going to do x minus 5 times the 9. The rest is just distributing. And you should end up with an x to the third, like we said before, because there's 3 solutions. So we have x to the third minus 5x squared plus 6x squared minus 30x plus 9x minus 45. Holy cow, jeez. This and this are going to cancel to be just x squared. This and this are going to cancel to be negative 21x. And then you should have the final answer there. X cubed plus x squared minus 21x minus 45. There we go. First thing, there's going to be a graph that's drawn. Hopefully it's not hand drawn like this one, but that's okay. So we have 1, 2, 3. So 1 here, 1, 2, 3, 4. Okay. There's a solution there. 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 All right, so it bounces here. Just threw an extra turn in there. There we go. Okay. And, oh, wait, hold on. I forgot to go through this. There we go. I had to go through that one for the y-intercept, so just wanted it to be exact. All right, so the problem would ask something like, number 1, what is the leading coefficient's sign? Is it positive or negative? So leading coefficient sign. Is it positive or negative? You would just circle one or write one down, I mean. Number 2 is, what is the lowest possible degree? Okay, make sure you write down how to do that because you can use that formula tomorrow in your notes. All right, what are the x-intercepts? What are the y-intercepts? Okay, 4-question quiz asking all those things. Take a couple minutes to answer that out. Set timer for 2 minutes.
Okay, 2 minutes and counting.
Take it easy. All right, sorry about that. All right, let's go over this. So the leading coefficient sign, is it going to be positive or negative? Just yell it out. Negative, very good. Okay, this is going to the right. If it's going down, it's going to be negative. That's just the way it is. Okay, lowest possible degree. So you take the number of turns and you add 1. So there's 1, 2, 3, 4, 5. So that means it should be the lowest possible degree is 6, and it's even. And if you notice, evens always go in the same direction. So the fact that that's going in the same direction, it definitely shows that it could be 6. Now it could be more than 6 because technically speaking, that bounce this has an even multiplicity right here. But what if it was to the 8th power? You know what I mean? If it was to the 100th power, then you would have way higher degrees here. So that's why I always ask for the lowest. It would be 6. Okay, but again, it could be more. Right, and then right here, x-intercepts, you should have -4. You should have -1 multiplicity 2 because it bounces. You should have 2 as well. Okay, I should have told you to put the multiplicities in there, so I will try to remind you tomorrow. And the last one, the y-intercept, is just 1. Okay. Now, one thing that I do want to show you, because it's directly related to what we're doing right now in 2.2, is this one right here has one solution, and then there's 2 solutions here, and then so that's 3, and then 4 solutions there. But technically, you should have 6 solutions. So where are those other 2 solutions if we only have 4 real ones? Anybody know? They're not real, then they're imaginary. So those other solutions are imaginary. You cannot find them by looking at the graph, nor will I ever ask you to do that. Okay? If you wanted to, you can make an equation for this. We're not doing this on tomorrow's quiz, but if you try to make an equation on this, it will not work. Because you're missing two other factors here. Okay, we only have 4 factors when we should have 6. So you can't actually do that. We're going to eventually get to how to do that like later on in 2.2, but for right now, we don't really need to worry about that. Okay, so this is what your quiz is going to look like tomorrow. 4 questions. There's a graph that's given. It's going to have less turns. Remember, I told you I made this one harder, so it's going to be less turns on this. So it should be a little bit easier to work with. Okay. Your homework is to finish 222, the 11 through 15. There is a video for those problems as well. Factor theorem is directly related to all this as well because we're making all this stuff in factored form. So I did try to make this unit as cohesive as possible, where it all blends together.